Hey guys, these are the horizontal motion in one direction notes for Unit 3. To go over a few definitions, we've got motion takes place over time and it depends on the frame of reference. Your frame of reference is that vantage point with respect to which the position and motion of an object may be described. And so motion technically occurs when an object changes its position relative to a reference point. So the example here I have on the screen is a boy standing on a train. So if our frame of reference is just looking at this boy standing on the train platform, he would be standing still. If our train is moving, in this case it says from left to right, that boy would be moving. If we're standing off to the side, watching this train go by, we're seeing this boy rush past us on this train. Why he's standing on a moving train, not so sure. But he would be moving in relation to the ground, but he's not moving in relation to the train platform. So depending on what you're looking at, your frame of reference depends on if this boy is technically moving or not. All right, let's go over variables and direction. This slide is really important. The earlier you learn these, the easier this will be. So to keep things all like unison throughout this unit, we are going to assign things positive and negative. So anytime an object's moving to the right, we're going to call it positive. If it's moving left, it'll be negative. If it's moving up, that'll be considered positive, and down will be considered negative. So let's say I am throwing a baseball across the room. If I am going to throw it to the right, I would have a positive distance that the ball traveled. If I threw the ball up in the air, as the ball goes up, it'd be positive. If it's coming back down, its distance would be negative, right? And these are important when we work out the math of assigning these positive and negatives. So this is just to keep everything, everyone on the same page with this, right? For our variables, you'll see all of these in your different formulas. If you did not get a formula sheet or if you've lost it, you can download one on the website as well. We're looking at the top box of formulas on that formula sheet for this unit, right? So on your formula sheet, in all those formulas, you'll see all these different letters. This is what each of them mean. So if it's just a V, it's velocity. If it's VI, it's initial velocity. VF is final velocity. So initial velocity is what's happening in the beginning of your problem, and final velocity is what's happening at the end. So if we're saying a car started from rest and ended up going 70 miles per hour, the initial velocity would be 0 because it's at rest, and its final velocity would be the 70 miles per hour because that's what it's going at the end of the scenario. Okay? A D would stand for distance, or you also can use it as displacement. A is acceleration, T is time, and then if you see this triangle, it stands for delta, which means change. So if it was said delta D, it would mean change in the distance, right? So just make sure you learn these, you know them. I'm not going to quiz you like matching sections or anything like that on these, but you need to be aware of what they stand for when working out your formulas. All right, so we're going to go through some different examples, and we're going to use several of the different formulas on that formula page. Right. So the first example here, we have a runner traveling 510 meters east in 75 seconds. We want to know what the runner's average velocity is. So our average velocity formula is the first one written on your page, and we're not really going to use it all that much in this unit, but you still need to know how to use it, but it's probably the easiest formula out of all of them. So our formula for that is this one, V equals delta D over delta T. So that means change in distance over change in time. So we've got our distance of 510 meters, our time of 75 seconds. So all you're doing is plugging those in, type them in your calculator, and you should get 6.8 meters per second. Now, to get your units, in this case, you've got meters and then divided by seconds. So that's where those meters per second is. So when you write out your work, if you write the units in there, then you can see, okay, well, these don't cancel out. I'm left with them. All right. A lot of times people will just say, oh, I have velocity. I know that if I'm working with meters and seconds, it'll turn into meters per second. So, but you do need to include your units in your final answer, or you're going to lose a point or two on your quiz or test, right? Example 2, we've got a car traveling at 25 meters per second. It sees a stop sign up ahead, and it begins to slow down at a constant acceleration until it comes to a complete stop. It takes 10 seconds to do this. So we want to find our acceleration. So I tend on lengthy problems like this where you've got a lot of numbers, either underline each thing and label it above or create a list. So we've got VI is 25 meters per second. This is what the car is doing initially at the beginning, and then it sees a stop sign and stops. So our final velocity is 0. And this is taking place for 10 seconds. So we want to use these three things plus acceleration in our formula because we're solving for acceleration. So out of your formulas, there's 2 of them. I'm going to pick this one because it's set up for acceleration. So we've got VF, VI, and T. So we're going to plug in 0 minus 25. The order does matter. All right, so pay attention that you plug in the 0 and 25 in the proper order. Divided by 10. So negative 25 divided by 10 will give you negative 2.5. Right? You'll see a negative acceleration when your object is slowing down and a positive acceleration when it's speeding up, as long as it's moving in the positive direction. Units for this are meters per second squared because you have meters per second, and that is shortened into meters per second squared. All right. For our next example, we've got a car accelerating at a rate of 4 meters per second for 3 seconds. If its final velocity is 40, we want to know the initial velocity. So we are given acceleration, time, final velocity, and we want to know initial velocity. So we want a formula with these 4 things in it, and there are actually 2 of them on the formula sheet. The one we use in example 3 and this one. I choose to use this one most of the time because I just like how it's set up more, but they'll both get you the correct answer because they're both the same formula written differently. So you plug in your numbers. 40 equals VI plus 4 times 3. I left out the unit just to save some time when I type this up. You multiply the 4 times 3, you get 12. You would subtract the 12 over the other side, leaving you with 28. Your units for velocity, if you weren't sure, you've got final velocity given to you as meters per second. So you're saying, oh, I'm working with velocity again. It's also going to be meters per second. All right. You can also plug in your units and cross them out. Whatever is easier for you, do that. So anyway, your final answer is 28 meters per second. All right, example 4, a car is traveling at 10 meters per second and accelerates at 3.3 meters per second for 20.1 seconds. What's the car's displacement? All right, so we are given our initial velocity of 10 meters per second because that's what it's doing at the beginning of our question. And then acceleration is 3.3. Our time is 20.1 and our distance is unknown. So we want a formula with these things in it. Notice we don't have final velocity, so you don't want to use a formula with final velocity in it. And that formula that doesn't have final velocity in it is this one. We will use this quite a bit throughout the unit. To be honest, this is probably the formula you will use the most often in this unit. So get used to it. So we'll plug in the 10, the 3.3, the 20.1 into our formula. Now, when you're typing in this 1/2 into your calculator, I highly encourage you to type it in as 0.5. It saves you clicking on one button instead of 1 divided by 2. You're typing in 2 buttons instead of 3. And it's just less prone to errors when you're typing in fractions. I really don't like fractions. I like decimals, but this formula is written with a fraction. So anyway, a lot of people like to type it all at once. Make sure you're only squaring the 20.1. That 2 only goes to the t. It does not go to the whole thing. So I typed it in this half and then the other half. So 201 plus 666.62 gives you 867.2 meters. All right. And if you're working with distance, basically these meters per second are canceling out with the seconds, leaving you with just meters. All right. Then the last one, we are example 5. Starting from rest, your car accelerates at a rate of 10 meters per second. What is the distance the car would travel when it reaches a speed of 50 meters per second? So in this case, we have VI of 0 because it's at rest, acceleration of 10, and a final of 50. So now we have an initial and a final velocity, but we do not have a time. So we need a formula that does not include time, which is this one, right? So plug in 50 squared equals 0 squared plus 2 times 10. So I'm going to simplify that. 50 squared is 2,500. 2 times 10 is 20. And 0 squared is just 0, so it just goes away. So then you would just divide 2,500 by 20, and you get 125 meters. All right. So the real goal here is to, or process here rather than goal, I guess, is you are, looking at what you were given in the question. You're figuring out which formula will get you your answer you need. You plug in and you go. So the math part is all algebra skills. All right. The hardest part really for most people is going to be figuring out which formula to use. But if you make a list, you can look at your list and say, okay, which of my formulas have that in them? All right. With practice and stuff, it gets a lot easier. But please feel free. Let me know if you guys have any questions. Email me. or ask me in class or during tutoring if you have any questions, right? Hope this helps. See you in class.